So let's take a look at the cosine law. So in your workbooks, we're on page 189, and this is Trig lesson number 6. So if we take a look at this triangle ABC, and they've given us a couple of the lengths and one of the angles, if we try to use the sine law to solve for length BC, what we find is we don't actually have enough information. We've got angle A is 36 degrees. We don't know length A, which is length BC. We have length B, but we don't have angle B. We have length C, but we don't have angle C. So if you start trying to fill in the sine law, we end up with something like A over sine of 36 degrees is equal to 6 centimeters over sine of B is equal to 3 centimeters over sine of C. And so we don't have any of the ratios completed, we don't have any of the pairs, and therefore we cannot use the sine law. So our only way to then solve this is to then complete the right triangle by adding in some lines, so dropping the height down from vertex C and having that meet an extension of side length AB. And so when we see this, what can we do is we can now assign, let's say that this is X and this is our height, and so we can then say, well, the height is going to be opposite 36 degrees. We have our right triangle now, triangle ACD. So in triangle ACD, we can say that sine of 36 degrees is equal to the opposite, or h, over the hypotenuse, which is 6. And then to isolate for h, we multiply both sides by 6. So then h is equal to 6 times the sine of 36 degrees. If I want to find length BD, then what do I know is that I can find AD and then subtract 3 centimeters, subtract AB. And so we can say then that for X, or for, let's go with AD, so AD, we're going to say then cosine of 36 degrees is then equal to AD, or that full length of the adjacent divided by the hypotenuse over 6. To isolate AD, we multiply both sides by 6, so then AD is going to equal 6 times cosine 36 degrees. So if I want BD, then BD, or I've got that labeled as X, X is going to equal then AD minus 3. So X is also known as 6 cosine 36 degrees minus 3. So now that I have X and I have H, I can find length BC using Pythagorean's theorem. We know that X squared plus H squared is going to equal BC squared. So I could essentially find out what these lengths are. I can find H and find out that that is approximately 3.5267, and that decimal goes on. Similarly, the length BD is going to be approximately 1.8541, and that decimal also goes on. So I could substitute the actual numbers in, and for some of you, you may feel more comfortable by putting the actual numbers in. Others of you who are comfortable working with the expressions might say, hey, well, X is actually 6 cosine 36 minus 3. So I'll put down then 6 cosine of 36 degrees minus 3, and then I'll square that, plus H, which is 6 sine 36 degrees, and I will square that, and that will equal BC squared. So if you enter that all into your calculator all at once and hit enter, we will see that BC squared is approximately 15.8753. And if we take the square root of that, we will see that BC is square root, so that is approximately 4.0 centimeters rounded to the nearest tenth. So if we take our calculators then, so let's just take a look. Oops. I'll show how we can enter that in. So let's just clear the screen then. So if I put in, I would like 6 cosine of 36 degrees minus 3, and we can close the bracket. Whoops, I don't want to do cosine of 36 minus 3 or cosine of 33. It's just cosine of 36, and then I'm going to subtract 3. And close that bracket. We'll square that, and then we will add, open bracket, 6 sine of 36 degrees, and close the angle, close the bracket for all of 6 sine 36. We'll square that, and so that gives us BC squared. That's our 15.8753, and on it goes. And then we can take the square root, a second square root, and we want to insert the answer. So the easiest way to do that is second function of this negative, which is the answer. So it inserts the last answer here. Hit enter, and we get 3.984, which rounds to the nearest tenth as 4.0 centimeters then. So it's very doable to find length BC using just our trig ratios along with a few other steps, but it's not very efficient. So that's why we come up with the cosine law. So flipping the page then, the cosine law is a squared equal to b squared plus c squared minus 2bc cosine of a. So how is it that they come up with that then? So let's take a look at first triangle ACD. So they've labeled length CD as h, the height, length AD as x, and the hypotenuse AC as b. So we're going to bring in these variables h and x, but because they're not going to be part of my triangle ABC, then ideally we're not going to have those variables within the formula. So in triangle ACD, or ADC as they've got it, if we take a look at cosine of A is adjacent over hypotenuse, so AD over AC, or otherwise known as X over B. If we want to isolate for X then we multiply both sides by B. So then if you think about it, we've got originally cosine of A is equal to X over B. If we multiply both sides by B, these B's cancel out. So X is then equal to B cosine of A. On the other hand, let's look at the other part of this triangle. So we'll just tuck that piece away. So if we look at triangle BCD, what do we know is with Pythagorean theorem that BC squared will equal CD squared plus BD squared, or A squared, A being the opposite of angle A, is equal to height squared. So here BD, we could bring in another variable, but ideally we've already got these two extra variables of x and h. So what do we know is that length AB is also known as length C because it is opposite vertex C or angle C. So if we know the whole length is C and the distance from A to D is x, then B to D must be C minus x. And so what do we know is Pythagorean theorem is going to say C minus x squared plus h squared will equal a squared. Then you guys did last year is c minus x squared. If we expand that, so it's c minus x times c minus x, then that is of course c squared minus cx minus cx again, and then plus x squared. Clean that up, and we've got c squared minus 2cx plus x squared. If we rearrange that, so we take the x squared and the h squared together, because those are two of the variables that we don't want to have, h squared plus x squared, we'll take a look in this red triangle again, ACD. Hey, x squared plus h squared, well, that's going to be part of Pythagorean theorem to find b squared. So that's why it is that we can replace h squared plus x squared is the same as b squared. And then replacing this x here, remember what we did back on the left-hand side with triangle ACD is x is equal to b cosine A. So we'll substitute out the x and put in b cosine A. And so with just a little bit of rearranging with alphabetical order, we have cosine law, a squared equals b squared plus c squared minus 2bc cosine of A. And so there's some other slight variations on that. By rearranging that triangle, we can also say b squared is equal to c squared plus a squared minus 2ca or 2ac cosine of b. So what do you want to notice is that we've got the length that we want to find is the one that's isolated. We have the corresponding angle. The other two legs are being squared, or the other two lengths are being squared and added, and then those are the two same lengths that's being multiplied by 2. So that comes into play anytime we have a triangle where we have two given lengths and we have the angle that is between them. And so that's why they're saying we have the side, the angle, and the side. So side, angle, side. Okay, so let's take a look at class example number 2, so which happens to be the same as class example number 1 that we had taken all that effort to solve with multiple steps using our basic trig ratios and Pythagorean theorem. So based on this, we're trying to find length BC again, which is also length A. Opposite angle B is length B, and opposite angle C is length C. So with this, we know that A squared is equal to B squared plus C squared minus 2BC cosine of A. So substitute in, what do we know is 6 squared plus 3 squared minus 2 times 6 times 3 times the cosine of 36 degrees. And again, if you put that right into your calculator, it will give you 15.8753 with some decimal places. We take the square root of the answer, and once again, it confirms our answer of approximately 4.0 centimeters. Excellent. Let's go on to class example number 3. So it says find the length to the nearest tenth of a centimeter of the third side of triangle PQR. So we know QP is 1.7, so let's label that onto the triangle. QR is 3.1 centimeters, and angle PQR, so PQR, or we look at vertex Q in the middle there, is 110 degrees. And so we're trying to find the third length, or length Q, so isolating for Q. So I'm just going to use those letters in the formula. So rather than A, B, and C, we'll use P, Q, and R. So isolating Q squared, that's the length that we want to find. So we'll take the sum of the square of the other two, so P squared plus R squared, then minus 2 and times P and R. Those are the two that I'm squaring and adding, and then times cosine of the corresponding angle of the length that I want to find, so cosine Q. Let's substitute in what we know. So P is length QR, so that's 3.1 squared plus 1.7 squared, which is length R, minus 2 times 3.1 times 1.7 times cosine of 110 degrees. So enter that all into your calculator all at once, and we will find out then that q squared is approximately 16.104 with a few decimal places, taking the square root of that answer. So we've got that q, or the third length, PR, is approximately 4.0 centimeters. And that's just a bit of a coincidence there. So on to the next one, class example number 4. So we've got Bellevue, which is 30 kilometers north of Ayr. So let's put in Ayr, and we'll conveniently label that A. Bellevue, we'll say north is directly straight vertical above, kind of like going to your positive y-axis, and that is Bellevue, and that is 30 kilometers. Then we've got Churchville, which is 18 kilometers northwest of Ayr. So if we've got Bellevue being due north, due west is going to be this way. So northwest is going to be directly in the middle, and that's going at a 45-degree angle then. And we're going 18 kilometers. So part of it is certainly how you're drawing it. It doesn't have to be perfectly to scale, but certainly reasonable is best because it gives you an idea of what it is that you're looking for. So I know that lots of people are tempted to draw it as A and B, and just to make pretty right triangles, as we often try to do, and to put C over here. But the issue is a few problems we run into. One is the fact that because you've drawn it as a right triangle, your brain's going to tell you that it wants to use Pythagorean theorem. But we don't know for sure that's a right triangle. What we do know for sure, actually, that could say, no, it's not a right triangle, is that would tell us that AC is the hypotenuse, and 18 cannot be longer than one of the legs. So it definitely is shorter. So please try not to draw it as a right triangle if you know that it's, or if you're not sure that it is a right triangle, because that will then just kind of play with your brain as to, should I use Pythagorean theorem when perhaps you should not. So they're looking for the distance between Bellevue and Churchville, which is length A. And so because we have side, angle, side, we know that we need to use the cosine law. So then again, A squared is equal to B squared plus C squared minus 2BC cosine of 45 degrees. So hit pause and try going through your solution and come back and take a look. So if we take a look at the solution, then we've plugged in the numbers for B and C, being 18 squared and 30 squared, minus 2 times 18 times 30 times cosine 45 degrees. Enter that all into your calculator all at once in one single key sequence. We'll end up with the fact that A squared is 460. Decimal 32 and some additional decimal places there, square root that, and looking that it wants us to round to the nearest kilometer, so that distance is then approximately 21 kilometers. So taking a look then, what happens if we have a missing angle that we want to find? So if we take a look, we've got A squared is equal to B squared plus C squared minus 2BC cosine of A. If we want to try to isolate cosine of A, we're going to start by subtracting B squared and C squared. So now we've got negative 2BC cosine of A is equal to A squared minus B squared minus C squared. And then at that point, easiest piece first would probably to be multiply both sides by -1. So if I multiply both sides by -1, then this side becomes positive 2BC cosine of A is equal to, this is now negative A squared, this is positive B squared, positive C squared. Then we'll divide both sides by 2BC. And so then that leaves us with cosine of A is equal to, and let's take that negative a squared and put that on the end. So we've got b squared plus c squared minus a squared over 2bc. And so that is going to be used when we're looking to find an angle, but we have all three lengths. So my suggestion, you don't need it in your notation, but at the same time, putting it into your notation is going to be helpful for using your calculator, is making sure that you are going to do all of the operations in the numerator and the denominator and then divide at the very end. So if we don't do that and people are just entering into their calculator b squared plus c squared minus a squared divided by 2bc, what's going to happen is your calculator is going to follow order of operations, and it's only going to divide a squared divided by the 2, which is going to be incorrect. And so while we don't need the brackets if you're using the fraction function on your calculator, without using the fraction function on your calculator, you need to separate out the numerator and the denominator with parentheses. Okay, if we're going to rewrite it for cosine of b, well, taking a look here, what do we know is the other two lengths that are not b are going to be our a squared plus c squared, and then we're going to subtract b squared and then divide by 2 times a times c, so the other two lengths. So similarly, cosine of c would then be a squared plus b squared minus c squared divided by 2ab. Okay, so let's take a look then at class example 6. So given those three lengths, we want the largest angle of triangle ABC. So what do we know is that the largest angle will be opposite the largest length, and therefore since the largest length is 14.7, the largest angle will be angle A. So that tells us that cosine A is what we're looking for. So the sum of the squares of the other two lengths, b squared plus c squared minus a squared over 2bc. So if we fill in our numbers, then we know that it's 8.9 squared plus 12.6 squared minus 14.7 squared, all divided by 2 times 8.9 times 12.6. And again, if you're entering this into your calculator, remember that you want to put parentheses around your numerator, parentheses around your denominator, and that will equal cosine of A. So that should tell us then that cosine of A is approximately going to be the ratio 0.0975. And then to find the actual angle, we want to do the inverse cosine. So A is equal to the inverse cosine of that ratio. So that tells us that angle A, that largest angle, is 84 degrees. So looking at that on your calculator, then what should we be able to see? So if you're not using the fraction function, then we want to open up the bracket for the numerator, and so we would have b squared, so that's 8.9 squared plus 12.6 squared, then minus 14.7 squared. Close the bracket for the numerator, then divided by the denominator, which is 2 times 8.9 times 12.6. So it's that numerator divided by the product in that denominator, and that will give us the cosine ratio. Then we want to do the inverse cosine of that answer, so second answer, and hit enter, and that is our angle of 84 degrees. let's take a look at class example number 6. So it's saying two ships set sail from port P. One heads 7 kilometers to point R. The other heads 8 kilometers towards Q. And the distance between R and Q is 13 kilometers. So the angle between the directions that we're looking for is angle P, or angle RPQ. So again, setting it up, we know that cosine of P is then going to equal, and hit pause right now and see if you can try to figure out what that ratio will look like then. Okay, so it should say cosine of P is equal to R squared plus Q squared minus P squared, and that is all divided by 2RQ. Go ahead and substitute in your numbers and see if you can tell me what angle P is. So you should have found that cosine of P, that ratio is negative 0.5. So why is that negative? Well, that brings us back to, well, when is our trig ratio going to be negative? Specifically, when is cosine negative? Cosine is negative in quadrants 2 and 3. That's when it's negative. So quadrants 2 and 3. But we can immediately eliminate quadrant 3. Why? Because we're talking about a triangle. So in a triangle, you can't have an angle being 180 degrees, or definitely not over 180 degrees, so it must be in quadrant 2. So if we want to stay consistent to what we've been doing, then we know that if we take the reference angle, can be found by doing the inverse cosine of the positive, or the absolute value of 0.5. So our reference angle is going to be 60 degrees. Because it's in quadrant 2, then angle P is going to equal 120 degrees then. What other people have found is if you simply do the inverse cosine of negative 0.5, it will tell you 120 degrees. But it's good for consistency's sake, especially because in some questions I'm actually asking you for all possibilities of the angle. So it's nice to know that if we always take the inverse inverse trig ratio of the positive value, that will give us our reference angle. Okay, so please complete your assigned questions and let me know if you have any additional questions along the way.